And welcome everybody to the daily space weather. We're looking at the sun here in ionized iron. As coronal mass ejections occur, we see a coronal hole rotating in down here in the southeast. It's quite large, it's South Pole oriented, it's well defined. And we've been proven over and over again to be correct. So as coronal mass ejections continue, solar activity generally drops. We're seeing quite weak activity here from the closest star, despite coronal mass ejections happening. So looking at the perspective from stereo A at Lagrangian point 5, located out here, this is the left pane here. So ignore this one for now. The left pane, you can see coronal mass ejections that are sort of earthly directed, but not really. They'll be missing the Earth to the west, at least according to the preliminary data that we see. So anyway, there's the view from stereo A, again at Lagrange point 5, and let's go to Lagrange point 1 to look at the LASCO C2. So from the LASCO C2, you can see, looks like all of the ejecta we are expecting to miss the Earth to the west. So you can see we don't see any ejecta here in the north, or in the south, or in the east. It's all headed out to the west. So keep in mind this event is actually ongoing right now. And again, there's the view once again from stereo A. The coronal mass ejection watch actually continues here. We have to wait until the ejection is complete. So there are both panes. Stereo A, Lagrange point 5 at the left, and the SOHO LASCO C2 Lagrange point 1 at the right. Here's some more imagery of the closest star in colorized magnetogram. The only sunspot we have is 2839. Don't be surprised to see us drop back down to a sunspot number of 0 today, as sunspot 2839 is indeed looking weak. So we'll zoom in a little bit so you can see it. It may already be gone by the time we're done with the video. It looks like the trailing umbra here has sort of remained intact and the leading umbra has gone away. So we'll be taking a closer look at that at the end of the video. And here's a diagram of the solar system if you're wondering where objects are. Here's where they are now. And there's where things will be in a week on the 15th. The radio flux has dropped all the way down to 76 solar flux units. Yes, the sun puts out radio frequency. It emerges from the upper chromosphere and the lower corona. It's the 10.7 centimeter radio flux. Here's the 1-year chart of it. You can see it dropping all the way down to 76. And the sunspot number may be dropping down to 0, which is this red line. The black line up here is the radio flux. That's from solon.info. No solar storms forecasted, although we are expecting a small uptick here. NOAA forecasting a KP3 for global geomagnetism. And we do have a coronal hole wind stream likely on the way with that large, well-defined coronal hole. And let's actually cut back to that for a quick moment here. Back to the 193 angstroms view. This is the coronal hole that we're talking about. This one down here in the southeast, it's quite well defined. And again, there's the full disk view in 193 angstroms. Continuing on to look at some more data here, like global seismicity. So the earthquake drought continues, folks. We've only seen one 7 magnitude earthquake in the past 90 days. It's a massive earthquake drought, and even 6.5 plus magnitude earthquakes, we've only seen one in the past about 45 days here. That's the 90-day bar graph of global seismicity. And if you look at previous years, you can see how often 7 magnitude earthquakes occur and what a drought we are indeed in right now. Earthquake droughts end in large earthquakes. Let's roll up the list of the past 24 hours from USGS. So we saw some here in the 5 range. Nothing in the 6 range, it looks like. There was a 5.3 at Taiwan and a 5.1 at Indonesia. The Indonesian one was over 100 kilometers depth. There was a 4.5 at Fiji, over 500 kilometers depth. Chile saw a deep quake as well, a 4.7 magnitude, 118 kilometers depth. South Africa and the Sandwich Islands both saw 5+ magnitude quakes here, very close to each other in time. Those only about 15 minutes apart. 5.1 and a 5.0 magnitude for those. Another 5 magnitude quake here at Taiwan. That's a 5.2. Tajikistan saw a deep quake. There was also a 5.0 at the South Sandwich Islands region. A deep quake at Fiji at a 4.2. Timor-Leste saw a 4.5 at 163 kilometers. And by the way, that 4.2 at Fiji was over 570 kilometers estimated depth. And we see a swarm in the Caribbean as well. The largest... Actually, let's zoom in on this area. So a little earthquake swarm there in between Puerto Rico and the Isle of Hispaniola. Actually, really all around Puerto Rico. And let's reset that map. And there we go. Continuing on to see volcanoes. We've talked earthquakes. Now it's time to talk volcanoes. And apparently there was a phreatomagmatic burst at Tal volcano. Let's start at the top. Karimsky on the Kamchatka Peninsula, exploding 10,000-foot ash plume there. Suminose Jima, flight level 060, 6,000-foot plume of volcanic ash over the Ryukyu Islands. Tal, which has been producing a little bit of VOG at Manila, back to a little bit higher sulfur dioxide emissions here. Not nearly as high as the record breakers that we saw a couple of days ago. So Tal exploding. No word on the size of the volcanic ash plume there. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Sangre exploding, 20,000-foot ash plume over Ecuador. Another Ecuadorian volcano, also Revenador, exploding, flight level 140. It's a 14,000-foot ash plume. Sabancaya, creating volcanic ash over Peru to the tune of a 22,000-foot ash plume. And Copahu, which is near the Chile-Argentina border, is at an elevated state of activity. So we see nighttime incandescence there from the crater. And if you're visiting that volcano, please don't pole vault the caldera. It could be unhelpful. This public service message brought to you by smAshomash.com and by our generous patrons. Next, the GOES X-ray flux here, getting back to some sun-facing instruments here on the GOES 16. No major solar flares over the past 24 hours. Another prime example of how solar flares are not required for coronal mass ejections. Here's the proton flux. None of those coronal mass ejections have been headed our way. We would have probably warned you ahead of time, especially if you were a patron. But we don't see any spikes in the proton flux. Here's the GOES magnetometer over the past 3 days, and we're seeing some pretty spiky patterns happening here. There is a bit of a tug-of-war happening in the heliospheric current sheet, which is our next frame. Anyway, that's the 3-day chart of the GOES magnetometer. And here's the heliospheric current sheet in terms of polarity. South pole-oriented polarity in red, North pole-oriented in green. And Earth is solidly in a South pole current sheet. Again, the coronal mass ejection watch continues, as it is not yet complete. Here's the line of sight ecliptic plane field plot. The same data essentially, just from the perspective of we Earthlings. And here's the line of sight coronal hole plot. You can see this large, very well-defined South Pole-oriented coronal hole. We're expecting that to produce a geo-effective stream of coronal hole high-speed wind in about 4 days, especially if it remains intact or indeed grows or stretches even farther toward the equator. So here you can see great imagery here of the coronal hole. It is South Pole oriented. And sunspot 2839 again has been degrading for the past 24 hours, certainly. Here's the KP index, a measurement of global geomagnetism, currently at 1, geomagnetic calm conditions. Next, the real-time solar wind. It's been pretty uneventful here in the past 24 hours as well. And we actually saw the density recently drop off a little bit, all the way down to 3.77 protons per cubic centimeter. Solar wind speed only 318 kilometers per second. It's like solar minimum conditions, folks. Next, looking at magnetohydrodynamic pressure in the geospace. So this should be 4 hours of data. We'll let this play all the way through. And we're expecting a little drop off here in the pressure right at the end of the geospace magnetosphere movie here. You're looking at nanopascals, by the way. It's all based on a space weather modeling framework, and indeed you can see the bow shock region losing a little pressure there with that drop off in solar wind density. Here are ground magnetic perturbations, geospace delta B, changes to the Earth's own B field. We showed you the sun's. Here are the Earth's B field perturbations, changes to the Earth's B field, geospace delta B. It's 4 hours, like the other geospace magnetosphere movie. Significant perturbations here, south of the Atlantic Ocean, Africa, and South America. It's a polar excursion. Now, we do regularly stream live to Twitch, by the way, twitch.tv/smashamash. Check out the mobile app there. It'll alert you when we go live, and we'll be going live in a moment for our meteorology segment. We would most advise all of our viewers to press like and subscribe on YouTube. It's where most of our content's located. Check out our playlists as well, youtube.com/smashamash/playlists. Did you see our live stream yesterday? We're doing a weekly Wednesday live stream. So at 2 p.m. Eastern Time, every Wednesday we're doing a live stream. Here is a teaser from when we were talking about how Greenland is melting, and you need to sell your oceanfront property immediately because Greenland is melting, and it's very scary and very spooky, and pardon the sarcasm. Here's a clip.
Plants grow. Yes. Reduce your carbon output, you fools. Otherwise Greenland could melt.
Reduce your carbon output, you fools. Otherwise Greenland could melt. We're also on Twitter. And oh my God, we've gotten all the way to 156 followers on Twitter. I'm sure the content isn't throttled over there or anything. I'm sure algorithms have nothing to do with it, folks. Twitter.com/smashamash. And have you heard about I'll just leave that there. We're also on Discord. There's a permanent invite to our Discord channel on the homepage. Welcome to the Neo Renaissance. Congratulations on finding that our channel exists. Head to smashamash.com. Smashamash.org will redirect you. You can find our social media there. Today's featured product is available at the smAsho merch link if you click smAsho merch. Before we talk about that, let's talk about our mission. And you can find our mission on our forum. And we've got a cosmology forum, Earth and geophysics. You can link all of that on the homepage as well. That's the smAsho forum. And our mission is at smashamash.com/forum/mission. And here is the mission. It's to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects. Your weather comes from space. To connect and consult with media organizations to multiply our reach, hence videos like this one, to demonstrate cutting-edge proof-of-concept solutions to problems like growing indoor tomatoes in the wintertime, to publish scientific papers in a multidisciplinary manner, like, papers about the mechanism behind the solar polar field reversal cycles and the forecasting of coronal mass ejections are two that are in the pipeline currently. And I need to quit my job in order to do that full time. So please support us, whether it's by pressing like, subscribe, share, becoming a patron, donating, etc., picking up merch. Number 6 is to assist mankind by advancing the study of predictive phenomenon to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And last but not least, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion, as being ossified in your beliefs isn't doing science. Anyway, today's featured product is, and again, you can link to this right at the homepage at the smAsho merch. Today's featured product is the Vaccinate This Socks. And shout out to all of our viewers who picked up merch. Send us photos. We'll feature them. Maybe go to the Discord channel, and let me just show you where the link to the Discord channel is. If you go to social media, right here, That is a permanent invite link to our Discord channel. You need an invite to join a Discord channel, so we've made a permanent one there. And by the way, your vaccination status is none of my business either. Let's continue on. To thank our patrons, the true source of funding for the content. Thanks, patrons. Thanks to our new patrons. Thanks to our oldest patrons. Patrons are listed in order of lifetime contribution. And until you actually pay cash, you don't appear on the credit call list until the next month. So thanks again to our patrons. Patreon.com/SmashoMash is the URL. As our patrons are making it more and more likely for these videos to continue to exist, remain publicly visible, and free for all to view. Patreon.com/SmashoMash for the earliest alerts and all kinds of other multimedia stuff that nobody else gets to see. Let's look at the astronomy picture of the day. Did you know the sun appears 3% smaller at perihelion than it does at aphelion of the Earth's orbit? Yeah, that's right. Turns out in northern hemisphere winter, the Earth is actually closer to the sun. And in northern hemisphere summer, it's farther away, and that's why it appears 3% smaller. You can look at the astronomy picture of the day if you like at apod.nasa.gov. And we picked a random object. By the way, we are going to talk more about AU microscopii in the future. Today's random object is number 49 at the Neil Gorell Swift-Bat X-ray Observatory, which is an X-ray binary known as HD 8357. Yes, HD 8357, the X-ray binary. Quite spectacular imagery of it there. Let's take a look at it in some more wavelengths. Here it is in ultraviolet on the Galix. And you can see how asymmetrical the plasma is around this X-ray binary. And this is a typical thing that we see with X-ray binaries, as there is typically an ionized gas and dust disk in between the two objects. And at Lagrange point 1, they typically have an extreme UV output. So this is sort of a common feature with X-ray binaries. Let's see if it shows up on pan-stars. Here it is in the full spectrum at pan-stars. And you can see some funky light emissions from it there. Let's see what it looks like on the 2MASS. And there it is in infrared. A little more homogeneous there in terms of its thermal spectra. The infrared spectra of X-ray binary HD 8357. And here are the X-ray outputs from it. You can follow your favorite objects yourself if you head to the Neil Gorell's Swift Observatory, the Burst Alert Telescope. Anyway, there are the X-ray transmissions from it over the past 16 years, over the past 30 days, and the daily chart. And there it is once again on the 2MASS. That's infrared light. That's today's cosmology segment. We integrated into the daily space weather today. We don't always do that. Make sure you check out our playlists, as we've got hundreds of cosmology segments. YouTube.com/SmashoMash/playlists. Next, looking at the electron flux around planet Earth, we don't see any charging hazards. It's all in the green. Here's the 1-year chart of the electron flux from Solon.info. And we're at low levels. When the coronal hole wind stream arrives in about 4 days, we can expect to see extremely low levels and chaotic electron belts. But here's the 3-day chart. Low, but not cratered, levels of electron flux. Here's the model, the forecast model, that is. That's the NOAA forecast for electron flux, and they're expecting a flatlined electron flux. After about this period, we can expect to see a dip, where we'll see some of the lower levels that we ever see. And here's a diagram of Earth's Van Allen belts to put that into perspective in terms of miles. Here's the total electron content forecast. So this will show you where likely GPS errors would occur. It's showing you the electron density for the entire air column, all the way up to tens of thousands of miles to where your GPS satellite is located in a geosynchronous orbit, down to your handset. And it's a little bit chaotic here. And we've demonstrated time and time again that the lower the levels of electron flux are, the less organized these blobs of electron density indeed are. So we're seeing fairly disorganized blobs here. Some GPS errors occurring at nighttime in unexpected places, perhaps. Next, we'll look at the ionosphere, the F layer, which is located about 300 kilometers. It's just one slice in vibrational frequency. And let's load that up, the F layer of the ionosphere. By the way, this is courtesy of Australian Government Bureau of Meteorology. Make sure that's on screen, and it looks good. So it should be 1 day here of ionogram, and each blob represents 1 megahertz, 1 million vibrations per second, the vibrational frequency. And we're seeing some anomalies once again here. In this area. Right there, you're seeing some surprisingly high vibrational areas here stretching way up toward the North Pole. Right in there. As well as quite far south into the South Pacific. Some a little bit anomalous ionospheric behavior going on there. Nothing too crazy. Let's bring up the latest image. That is from 7:45 Universal Time. And we just did our meteorology segment. Make sure you check that out if you haven't been looking at them. Meteorology segments, we've been doing them daily as separate videos. That's your teaser. Let's get on to bonus features. The bonus features will consist of the latest hydrogen alpha imagery from the ground-based solar observatory at Udaipur, India. We see significant filaments down here as well as up here still attached to the solar corona. That's why the coronal mass ejection watch continues. It's not even done unfolding, the one that we forecasted 2 days ago. So in any case, there you go. Coronal mass ejection watches continue, and we're continuing to watch them. Next, the GOES 16 SUVI thematic map, which is showing prominences out here. It's a bunch of plasma hanging off the western limb, rather. Also prominences hanging off of the eastern limb. Also filaments in between the sun and the earth, as you can see right here, and some coronal holes. So despite going back down to 0 sunspots, perhaps there are still significant features. So here's the latest refresh of the solar intensity gram to see just about nothing going on. Sunspot 2839 barely has an umbra. In fact, I don't even know if that would be considered an umbra. Anyway, there's the full disk view. I think we're going to be back to 0 as a sunspot number. Here's a colorized magnetogram. And here's a little more imagery to close things out. So here's a composite view from the Solar Dynamics Observatory. It's actually 3 different ionized states of iron here. 211 angstroms, 193 angstroms, and 171 angstroms. And we'll zoom in a little bit for your viewing pleasure. Thanks for tuning into the Daily Space Weather. Congratulations on finding our channel. And may that solar wind be at your back.